Welcome back, my friends, to Module 6, Lesson 2, where we will examine the process for conducting ANOVA using SPSS. Now, I would encourage you that you might want to set a computer beside you when you watch the video and also navigate through SPSS. It shouldn't be very hard for you, but I'm going to show you the screen pictures so that you know and show you where you go and lay out what you do. To conduct ANOVA, first establish the protocols. Now, the protocols are that you have independence, normality, and homogeneity of variance. And then I will remind you of the 6-step plan. You state the null and the alternate, the critical value, the test, research, the conclusion, and the statement. Now, in conducting ANOVA, there will be some unusual things in step 4. We will find significance, and if the significance indicates that we reject the null hypothesis and there is a difference, then you're going to want to go forward and conduct the post hoc test. And then if you conduct the post hoc test, you're going to want to interpret it where the differences are. We know where they are and we know what they entail. Then you will draw your conclusion and you'll write your findings into statements. Now, the test analysis of variance includes independence. Independence means that one population does not control the other. The population of parents and the population of children are not independent because probably the children control the parents more than the parents control the children. But if you were to do something like you give a test, give a retest and a retest, those are not independent, those are dependent. So independent means one population does not control the other. Normality means that your curves and your populations, that the distributions are approximately normally distributed. We have 2 factors that we look at. We look at skewness, that means they don't fall to one side or the other, and we look at kurtosis. Now, for skewness and kurtosis, we need a value between -3 and 3. Skewness talks about it being left skewed or right skewed. Kurtosis talks about it being too flat or too sharp to be normally distributed. If the skewness and kurtosis fall between the values of -3 and 3, then we're going to say that the curves are approximately normally distributed and we can proceed. Homogeneity of variance means that the curves have an equal standard deviation, so they're equally spread. You don't have the situation where you have this narrow curve and this big fat curve and this other medium fat curve, and you're trying to compare them because they're not enough alike for the comparative to work very well. I went back to this slide to talk to you just a minute. Independence you would find from the problem, and there are ways to test independence, but I'm not doing that right now. Normality, what if your curves are just not quite normally distributed? Well, you can use what's called a non-parametric test. Non-parametric means that they're not normally distributed, or you could use ANOVA and declare to your reader that all of the protocols were not quite met, and the same goes for homogeneity of variance. Then if you declare it up front and then you conduct the ANOVA, what you're doing is you're telling your reader what limitations you have and let them make the decision accordingly as to how they apply the results. So let's move on with this just a minute. Now, ANOVA should follow the following steps. Now, these steps are pretty cool, but some of the steps are done together. I'll talk to you about how we do that. The first thing we do is collect the descriptives, including the skewness and kurtosis. What we're doing here is we're looking at protocols, but the process for finding skewness and kurtosis also provides for us the descriptives. We conduct the ANOVA to determine if a significant difference is present. If you find no significant difference, then you're through. If you find a significant difference, then you can go down and do the post hoc test. Post hoc test lets us look at where the difference is, and I recommend the Tukey test, but you use whichever one you desire. But if there is a post hoc test because they're significant and it tells us where it is, then you have to take those results of where it is and go back to your descriptives so that you can tell the actualities of it. For instance, you may find that population 1 differs from population 2, but the descriptives will help you know which one is larger and which one is smaller. Now, consider this problem. A procurement specialist, a purchasing agent, has randomly selected 30 resistors from vendor 1, 30 resistors from vendor 2, and 30 resistors from vendor 3 in order to look for differences in quality. Each resistor's resistance is measured with indicated results and test for significant difference between the resistors of vendor 1, vendor 2, and vendor 3. We're going to look to see if those actually differ. And here's a picture of what I've told you. We have 3 vendors, their populations. We took a sample of each one, and we're going to compare those 3 samples. Now, again, establish that the protocols are met when you conduct ANOVA, capture the descriptives, conduct the 6-step hypothesis test, proceed with the post hoc test if significant difference is established, and use the descriptives to understand the post hoc results. Now, establish that the protocols are met, capture the descriptives, conduct the 6-step hypothesis test, proceed with the post hoc test if significant difference is established, and use the descriptives to understand the post hoc results. Step 4 and Step 5 actually occur inside Step 3 if we find a difference. We establish the protocols. The independence says that the cases are, one does not control the other. Now, normality, we identify with skewness and kurtosis, and we have to enter the data using the variables vendor 1, vendor 2, and vendor 3. You will recall that when you conducted your difference of 2 means test, you had to, when you actually did the test, you had to have a variable named group, and then you had a variable that had the values in it. But when you did the differences of 2 means to look for skewness and kurtosis, you had to do vendor 1, vendor 2. This is just an extension of that. To find normality, and I'm going to show you how to do this, we're going to enter vendor 1, vendor 2, and vendor 3 into SPSS. And it would benefit you to have SPSS where you can look at this. Now, what I have done is logged into SPSS, and I have killed those screens that come up to get to this screen, the screen called variable view, so I can name my variables. I've named variable 1, variable 2, and variable 3, and I have limited them to 1 decimal. Now I've actually entered in the values in the data view. Here are the values that you were given in your problem set, and they've been entered. Now, if I want to analyze this for descriptives and to get skewness and kurtosis, the first thing I do is that I go up to Analyze, I select Descriptive Statistics and select Descriptives. Now when I do that, this screen comes up and I highlight my 3 vendors. I push this arrow right here, and when I do that, I now have them put in the variables that I'm going to examine. Now I need to look at the options that I have. And when I select options, I need the mean and the standard deviation. It will automatically give me the number. Maybe I want the minimum and maximum, but when I do that, I want to remind you, I push continue and then I select OK. And when I do that, I get this table. Now notice the table tells me the numbers, minimum, maximum. I may or may not need that. That's fine. That's interesting. But the mean is 99.2. The 105.1, 100.3, I rounded these off. Just because SPSS gives you a value doesn't mean that you run with that value exactly as it is. You determine how many decimal places you want. And then the standard deviation needs to be listed as 1 decimal place more than the mean. So we have the standard deviation. Now let's look at skewness and kurtosis. We notice that when we look at skewness and kurtosis, that the values of the skewness and the values of the kurtosis fall between -3 and 3. Therefore, we can say that the curves are approximately normally distributed. So we know they're independent because one vendor does not control the other. We know that we have normality, but that they're approximately normally distributed. We need to look at the homogeneity of variance next. And when you actually run the ANOVA, you select, and I will show you where to do that in just a minute, the Levine's test for homogeneity of variance. Remember, the variance is the same as the standard deviation. And you will get this table that comes up. I have selected based on the mean, and the significance is 0.249. Now, the thing we have to do here is interpret this. If there is a difference, then the significance will be less than 0.05. And if there is no difference, then the significance will be more than 0.05. So we discovered that there is no significant difference. So we've established independence, we've established normality, and we've established homogeneity of variance. So we meet all three conditions. When we ran the data, as I showed you a moment ago, look at when we ran the data. We got this table. Not only did we get the skewness and kurtosis, but we got the descriptive statistics as well. And what I've done here is just listed them so you can see them. We have the number, we have the mean, and we have the standard deviation, the skewness, and the kurtosis. So let's move on. And then we'll conduct the 6-step hypothesis test. We need to state the null, state the alternate, establish the critical value, find the test statistic, that's the significance of the ANOVA, and based on the significance of the ANOVA, we're going to move to our conclusion, and if we find there is significance, we need to run a post hoc test to see where it is, and we need to examine where it is against the descriptive, so we measure the extent of it. And then we write our findings into statements. Here's our null hypothesis, that the means are equal. The alternate hypothesis is that there's a difference in the means. How much error is acceptable? Well, we're already, see, we whipped through the null and the alternate hypotheses, not much to that. Let's accept 0.05. This is not a critical life and death value. 5% error is very acceptable for us. Now we find the test statistic. This is the likelihood that they're the same, and it's called a p-value or significance. Now, it corresponds to alpha. We set an alpha limit of 0.05, and we're going to find what the actual significance of the difference is. Using the software is much easier than having to go to a z-score table and look everything up. You just have your boundary of 0.05, and then you see what the significance is. So it gives you that with the test. So here we go. Now, to set up the variables to actually run the ANOVA, we have to do them differently than when we ran the descriptives and found skewness and kurtosis. We set up group. How many group variable? We have 3 groups. We then set up the resistance values, and we did that in variable view. We now go to data view, and notice we have group 1, and under it group 2, and group 3, and the values. You could have 100 groups if you wanted. Our problem just has 3. And once we do that, we go up and we select Analyze. We're going to compare means, and we're going to go to one-way ANOVA. And when we click on that, it comes up this way. Now, the group is the factor, and let me carry you back to that. Let's go back. The group is the factor, the resistant is the dependent, so we put them accordingly. And now we need to do some things like that. We want to look at options. We don't need the descriptives again. We already have those. The problem with getting the descriptives here only is that it doesn't give you the skewness and the kurtosis, and we need the skewness and kurtosis. But we do select the homogeneity of variance because remember, I told you that the Levine's test is part of the ANOVA. This is where we actually get it. So we continue with that, and now we select our options for the post hoc test, and we selected a Tukey test. We're going to continue and then hit OK, and we get this table. First table here is this homogeneity of variance. See, this is where the table comes up. But here's what's important, the ANOVA. Our significance is less than 0.001. Now, that's one of the new features of some of the newer versions of SPSS. It used to, well, something like this, it used to say, well, the significance was 0. Well, it's impossible to have 100% certainty that they differ. There's always a chance that something odd might happen. So it says, instead of saying 0, it says less than 0.001. And this means that the likelihood that they are the same is less than 1 in 1,000. That's very acceptable. So what we discover is that they differ. This means that there's a difference somewhere in those groups. Now, once we do that and we see that there is a significant difference, we have to run the post hoc test. And that's what we had told it to do, and it did that. Now, I want you to look at the post hoc results just a minute. Group 1 compared to Group 2 and 3. Group 2 compared to Group 1 and 3. Group 3 compared to Group 1 and 2. Group 1 compared to Group 2 is the same as Group 2 compared to Group 1, okay? We notice that as we read through this, that Group 1 differs from Group 2. So mu 1 differs from mu 2. We have a finding. We then look at but mu 1 does not differ from mu 3. That didn't meet the parameters. Mu 2 differs from mu 1 and mu 3, and then mu 3 differs from mu 2. Now, let's look at these 4 things that I've listed here. Mu 1 differs from mu 2, and mu 2 differs from mu 1 is the same thing. And mu 2 differs from mu 3, and mu 3 differs from mu 2 is the same thing. So what we in fact have are 2 statements. Mu 1 and mu 2 differ, and mu 2 and mu 3 differ. Now, so we go back to the descriptives. Mu 1, mean 1 differs from mu 2. We know that these differ. So it's really easy to say, okay, mu 1 is 99.3, or 0.2 should be. Mu 2 is 105.1. So if they differ, mu 2 is greater than mu 1. We know that. And we likewise know that mu 2 differs from mu 3, and mu 2 is 105.1. And mu 3 is 100.3. So we know that mu 2 is larger than mu 1 and mu 3. And of course, if we go back and we look at that, we see that mu 1 does not differ from mu 3. Mu 3 does not differ from mu 1. So the only differences we have are mu 1 and mu 2. And mu 2 is greater than mu 1, and mu 2 and mu 3, where mu 2 is greater than mu 3. Now, what we found is that in our decision, we're going to reject the null hypothesis in favor of the alternate because our significance was less than 0.001, and we established that the mu 2, the resistors 2 are greater than resistor 1, and resistor 2 is greater than resistor 3. So our conclusion is reject H0, and mu 2 is greater than mu 1, and mu 2 is greater than mu 3. Now, you put your conclusion into words for the non-statistically minded. The evidence indicates that the resistors of vendor 2 have a higher resistance than those of vendor 1 and vendor 3. Based on the findings of the ANOVA that we conducted, all things being the same, vendor 2 produces a better resistor than vendor 1 and vendor 3, so we would purchase those from vendor 2. Now, what we did is we compared 3 populations, we took 3 samples, we compared the samples, we found that they did differ, and then we ran a post hoc and found that 2 differed from 1 and 2 differed from 3. 1 did not differ from 3, and we found then when we looked at the descriptives that 2 is bigger than 1 and 2 is bigger than 3, so we would select resistor from vendor 2. Now, here's the process for conducting ANOVA again. Establish that the protocols are met. You have to have independence, normality, and homogeneity of variance. In other words, one does not control the other. The curves are approximately normally distributed, and they have a fairly comparable standard deviation, so the curves somewhat look alike. Once you establish the protocols, and in the process of finding skewness and kurtosis, you also capture the descriptives. You conduct the 6-step hypothesis test, and if you find that a significant difference exists, then you proceed with the post hoc, and once you find where the difference is, you use the descriptives to understand it more. Now, don't panic, my friends. You've got this. This really isn't hard. This is a lot of fun to do, and you're using software, and the software is doing the work for you. The only thing you really need to know is how to go through and run the values that you need and how to interpret them afterwards. You've got this. I'm proud of you.